we will introduce the quadratic polynomial. So first, a polynomial of the form ax squared plus bx plus c for a, which is not equal to 0, is quadratic polynomial. Then if b equals 0 and c, which is not equal to 0, then the quadratic polynomial will be ax to the squared plus c. Then we have b, which is not equal to 0, and c, which is equal to 0. Then the quadratic polynomial will be ax to the squared plus bx. Then at last we have b equals 0 and c equals 0, which is the quadratic polynomial for ax to the square. So first, here on the page we have to explain the general process. So first we identify a, b, c, then we determine the product ac, then we need to find two numbers as whole product, so as a and the sum, which is b. Then we rewrite the original given quadratic polynomial as ax to the squared plus bx plus gx plus c. Then we group the terms as following. In brackets, both of them, ax to the squared plus bx plus gx plus c. Then we factor out the greatest common factor of each part. The greatest common factor of a and p might be 1 or k. So if a and p are co-prime numbers, then the greatest common factor of a and p is 1, and then the first group as factor is x, ax plus p, and that we put in brackets. Then, if a and p are not co-prime numbers, then a is equal to kt and p is equal to kr. Then the first group is factored as kx in the brackets tx plus r. Then we factor out the greatest common factor of the expression, so the factoring is done. On this page, we have to explain the difference, which makes the leading coefficients, which is 1, or the same other integer. So in that case, the process is easier, and then we go through the steps 3 and j, which I have mentioned before. Or when we determine p and q, which we transform the quadratic trinomial as x plus p, that we put in brackets, times x plus q, and so the factoring here is done. So here we have 8n to the square plus 45n minus 18. A is 8, b is 45, c is minus 18. 8 times c equals 8 times minus 18, which is equals to negative 144. 144 expressed as a product of multiplies is the following here, put in graph. So since p plus q is equals b and b is 45, we list all the written pairs in the table and determine their sums. Here we have the table with the results. On the other side, we have, since b is 45, we get that g is minus 3 and p is 48. So we rewrite the given transformation, which is the following. 8n to the squared plus 45n minus 18 equals 8n to the squared plus 48n, which is minus n, 3n minus 18. Then we group the terms as the following. 8n to the squared plus 48n plus minus 3n minus 18. Since the greatest common factor of 8 and 48 is 8, or the greatest common factor is 8 and 48, which is equals 8, we have the greatest common factor of minus 3 and minus 18, which is minus 3, or greatest common factor of minus 3 and minus 18, which is minus 3.